let's take a look at today's daily math. So the first one asks you which model correctly represents the problem. So we're subtracting fractions in all three of these. But when we subtract or add fractions, what do we have to make sure of before we can add or subtract? What do we have to check? Zala?
The number fold.
Okay. Something has to be the same. What has to be the same before we can add or subtract? The bottom of the fraction, the denominator. Your bottom number has to be the same or you cannot add or subtract them. If the size of our pieces aren't the same, then we can't just start sticking pieces together that aren't the same size. We've got to make them into the same size. But if I look at these in all four options, I have 12th size pieces. So I'm ready to subtract. So let's look at option 1. We have 7/12 minus 2/12. 7 minus 2 equals what? 5. So is 4/12 correct? No, we don't even have to worry about the model because 7/12 minus 2/12 equals 5/12, not 4/12. So if I go on over to option 2, I have 7/12 minus 2/12 equals 5/12. Is that correct? Mm-hmm. Okay, so we're going to look at the model to see if it's correct. I have 1, 2, 3, 4, 5, 6, 7 pieces shaded. There's 8, 9, 10, 11, 12 pieces in the hole. So did they start with shading 7/12?
Yeah.
Okay. Are 2 of them taken away?
Yes.
How can we tell that there's 2 pieces taken away? What shows us that, Tommy?
This right here shows it kind of makes X's.
Yeah, it's like crossed out, like it's X's. They marked it out the other way to show that those are taken away. And if I look at that, that leaves 1, 2, 3, 4, 5 12th size pieces shaded that are not crossed out. So option 2 is the correct answer. Let's take a look at option 3. What's wrong with option 3? It says 7/12 minus 2/12 equals 5/12. Why is that not the correct answer? Why not, Chloe?
It marks out 4 spaces instead of 2.
Okay. They marked out the wrong amounts. They took away 4/12 instead of 2/12. What's wrong with option 4? 5/12 minus 2/12 equals 5/12. What's wrong with that, Bryce?
The 5 has to be a 7.
Yeah, that should either be a 7 or if they were going to say 5/12 minus 2/12, that would equal 3/12 instead of 5/12, right? So the equation's wrong in that one. All right, let's look at number 2. On number 2, they give you a rectangle. We know that the area of that rectangle is equal to what?
60 yards.
60 square yards. We know the length of that rectangle is what? 12 yards. And we're missing W, or the width. What's the area formula? How do we find area, Ainsley? Area equals length times width. So I know that 60, because that's the area, equals the length of 12 times W, which is what we're missing. So what does W have to equal? Area equals length times width. So we know the area is 60. The length is 12, and I'm missing the width. 12 times what's going to give me 60, Ainsley? 5. The correct answer is 5. If I multiply 12 times 5, that gets me 60. Alright, we should be really good at those area problems by now. Alright, here's the next one. This is one I want us to really talk about. It says complete the missing information for the equivalent fraction and the decimal form of the fractions. So we're pretty comfortable with fractions. We've talked enough about fractions that we at least understand what they represent. But what about decimals? That's something we haven't spent a lot of time on yet, isn't it? Okay, so decimals and fractions are interchangeable. They're two different ways of representing the same thing. If you have a fraction, what is that telling you?
It's a part of a whole.
It's a part of a whole. We don't have the whole thing yet. So let's go ahead and let's look at 1/10. 1/10 is equal to how many hundredths? So I have 1 out of 10 pieces, and I want to know what it takes, how many pieces I would have to have that same amount, except for my whole is broken into 100 pieces instead of 10. So to do that, what happens if I multiply a number by 1?
It'll be that number.
It's the same number, right? It doesn't change the number. 2 times 1 is?
2.
2. 10 times 1 is?
10.
1,000 times 1 is?
1,000.
2 billion times 1 is?
2 billion.
It doesn't change, does it? So when I'm finding an equivalent fraction or a fraction that represents the same amount, if I multiply it by 1, it's not going to change the amount that I have. So that's what I'm doing when I'm looking for equivalent fractions. So I'm needing to know how to get from 10th size pieces to 100th size pieces. What would I need to multiply 10 by
10.
to get 100? What is it?
10.
10. 10 times 10 equals 100. Do we all agree with that?
Yes.
So if I had
Number 1 is 10.
something split into 10th size pieces, how many of those would I need to have shaded so that I would have one whole?
All of them.
All 10 of them, right? So if I multiply by 10 tenths, that's the same as one whole. And so it's not going to change the amount I have shaded. It's just going to change the number of pieces. So 10 times 10 is 100. So I have to multiply 1 times 10, which is what?
10.
10. So that tells me that 1/10 is equal to or equivalent to 10 100ths. So A is equal to 10. Okay? Alright, so we've seen that. We've looked at some models showing tenths and hundredths being equivalent to, haven't we? So we ought to have at least a visual idea or representation of what that looks like. But then we get down here to the decimal form, and that's a little bit different. We hadn't really talked a lot about decimals. So we said, Ainsley told us earlier that we know decimal or fractions are part of a whole. I don't have a whole yet. So that's the exact same thing with decimals. It's just another way to write a number that's smaller than a whole. So let's think about place values. I'd have, in whole numbers, I have hundreds, then I have tens, then I have ones. Do I have anything smaller that's a whole number? Ones are the smallest whole number, aren't they? Okay, so then after the ones, there's a decimal point. And the next smallest place value is tenths. What's different about the word tens here and the word tenths? What's different about tens and tenths? Just what do you see, Tommy?
You add a T, H, and S to it.
Yeah. When I have decimals, those place values end with THS. No matter what the decimal place value is, it always ends with THS. That way I know the difference between whole units and decimals. So after tenths, the next smallest place value is going to be hundredths. There's that THS at the end to tell me that it's smaller than a whole. What do you think might come after hundredths?
1,000.
Thousandths. You're exactly right. Then 10,000ths and 100,000ths. It just repeats going the other way. The only difference is that we skip the ones. There's no once. There's not any such thing as that. It goes straight from ones to the smallest part is tenths. And we'll talk a lot more about that. So if you're still a little bit confused, don't fret over that yet. All right. But we need to know how we would write 1/10 as a decimal. If I'm writing 1/10 as a decimal, where do you think that 1 would go? In the tenths place value, right? So I have 0 wholes, decimal point, and I need to put that 1 in the tenths place value, which is the first place value after the decimal point. So it would look like 1/10 written as a decimal is 0, a decimal point, and a 1. So B is equal to 1. Okay? Then for C, we're representing 10 hundredths as a decimal. So what will I need in the hundredths place value?
You need
10 to be in the hundredths place value. So I have 0 wholes and 10 hundredths. 0 wholes, 10 hundredths. So C is equal to 10.
How come he's not showing up?
Okay. So A was equal to 10, B is equal to 1, and C is equal to 10. All right, let's go on and look at number 4 now. Which problem is solved and modeled correctly? Remember, which place value is the one right after the decimal point?
The 100.
Not the 100.
10.
Tenths. Tenths are the next place value after the decimal point. So does this first model show 7 tenths? No, that shows 7 hundredths. So we know that can't be correct. Okay, so then the next one, I have 7 in the hundredths place value. Does this model show 7 hundredths?
No.
No, that shows 7 tenths. All right, so now we look at this one. We have 7 in the hundredths place value. Does this show 7 hundredths?
Yes.
Yeah, I have 7 shaded and there's 100 in the hole. Then on the opposite side, I have 7 tenths. Does this show 7 of 10 shaded?
Yes.
Okay. Is 7 hundredths greater than 7 tenths?
No.
No. If I look at option 4, I have 7 hundredths shaded. I have 7 tenths shaded. And it says that 7 hundredths is less than 7 tenths. Is that correct?
Yes.
That is correct. Option 4 is the correct answer. Alright, let's look at number 5. It says to identify the fractions on the number line. I want you to ignore right now. Just completely ignore your answer choices. I want us to just look at the number line. What does our number line start with?
Zero.
0. And what's our last?
1.
0 and 1. So we have one hole represented on this number line, don't we? Between 0 and 1 is 1. One hole. So we're going to look and see how many equal size spaces there are between 0 and